Now I know you can't see this writing very well. It's very, very small, but I'll read it to you, so don't worry. And this is actually comes straight off of your workbooks or your PDF notebooks, pages, whatever you guys print up or whatever. So let's go through this thing. I want to build a rectangle I want to build a rectangular enclosure using 400 feet of fence. So let's see. If I have a rectangle fence, and this one's X, and I'll call this one L, and I don't know what L is, and I have 400 feet to use, then let's figure out an equation that would give me the what L is, because I want to figure out what L is in terms of X. So I know that 2X plus 2L is equal to 400. Are we cool with that? Yeah, exactly. There we go. 2x plus 2l equals 400. And I guess what I would do then is I would say, all right, 2l is equal to 400 minus 2x. And I would say something like L is equal to 200 minus x, because I just divided everything by 2. Done. That's pretty easy. So this is actually 200 minus x. All right. Now what I want to do is I want to figure out oh, okay, so that was question A. If one side of the enclosure is labeled X, where the units are X feet, what should the other base be labeled in terms of X? Well, it would be that. All right. Now what I want to do is symbolically, wait, I have an appointment later, so I have to do the work, but I'm listening to class. All right, yeah, okay, that's fine. All right. What I want to do is I want to symbolically figure out what the area is, and I'm going to write it as A of x. What that means is this is the area as a function of x. So the area of a rectangle is pretty straightforward. It's base times height, and this time the base is 200 minus x, and the height is x. So really what I have is a quadratic equation where I'll have 200x minus x squared equals my area. Are we cool? All right. What are the allowable inputs? What is the domain of A? Let me see. Well, what can go in? All real numbers? Sophia, I would actually say no. I would almost say 1 and 400. Or maybe 0 and 400. Yeah, because you can't, because if your x was 1, then you'd have a really long skinny fence. You know what I mean? And if your x was 400, then you would have a really tall well, I guess this would be a really short fat fence versus a really tall skinny fence. Looking at it from above, of course. And I would almost say that you can't have 400. I would actually say 0x 0 400. And I wouldn't put the equal to signs. The reason being is because if you had 400, then how wide would your fence be? It would be 0. You know what I mean? And that would kind of be a pointless fence. So I would say you're done there. Got it? All right. Our graph below, the area as a function of x. It should be appropriately labeled. Okay. So I know this. I know it's a parabola. And I know it's an unhappy parabola. And I know that the x-intercepts is at 0 and 200. Would you agree? Well, over here, this is our equation in standard form, and that's actually not what I want. But look over here, this is our equation in factored form, and that you can almost read off what your x-intercepts are. Got it? And then so my parabola will probably look something like that. Unhappy parabola, and it's going through these x-intercepts because I can get it from the factored form up there. That's what my thought process is, at least. What is the dimensions of the rectangular enclosure with maximum area? So if it crosses 0 area over here and here, I'm assuming that the rectangular, or that the area, the maximum area will give me is at x equals 100. Yes, the vertex is the maximum area. So I know that x is equal to 100. Let's figure out what the area is based off of that. So I can figure out in one of two ways. I know that if x equals 100, then L is equal to 100 as well, because 200 minus 100 is 100. And then that times itself is 100 times 100, which is 10,000, I think it is. So this part right here is A of 100 equals 10,000. Or I can just plug in my x into this equation up here, and then I would have 200 times 100 minus 100 squared. So that would be 20,000 minus 10,000, giving me 10,000. Did I do that correct? I think I did. Are we cool with that? So this is actually all of the math that I've taught you in the previous stuff, but I'm just applying it to the real world. Which is actually really helpful to us because, I mean, if you were a farmer and you wanted to have like the most amount of space for you to grow your crops in, and you had this much fencing, then apparently make it a square. Don't make it a rectangle, make it a square, because if the height is 100 and the width is 100, that's a square. Anyway, whatever. All right. What they want to do is they want to figure out what is the maximum area you can include, let's see. Using the graph, approximate the dimensions that would yield 8,000 feet squared. Okay. So apparently this height right here is 10,000. And we could use the graph to approximate 8,000. All right, I guess I will use Desmos to do that. Come on, Desmos, help me out. Desmos graphing calculator. And I think that the area is equal to, what was it, 200x minus x squared. And I don't think it likes the equal sign. There. Whoa, that is a very tall graph. Let me just zoom out. There we go. So it's a really tall graph. Let me see if I can change the settings on this. Let's see. The settings I want to go from, I want you to go from 0, or let's say -1. -1 to 200. Make it 201. -1 to 201, and then the y-axis, I want you to go from 0, or -1, to 10,000. There we go. We'll make it 10. There we go. We'll make it 100. There we go. Okay, good. All right. So this is my graph. And you want to approximate 8,000. So I would say 8,000 happens about, let's see, if that's 40, then that's 50 right here, that's 55. I would say 8,000 happens about 55. It also happens at about 145. X equals 145 or x equals 55 will give you a y value or a area value of 8,000. Now, Sophia is actually suggesting the better way to do it. So what I did was I used the graph to kind of approximate that. That's the this thing's about here. So if I drop this down to over here, I get 55. Do you guys see what I'm getting at here? But what Sophia is suggesting is she's saying, well, what I want to do is if this is the equation for your area, 200x minus x squared. That was it, right? Yeah. If that's the equation for your area, what I want to do is do this. Set it equal to 8,000, 200x minus x squared, and then solve for it. Fair enough? Okay. Now, Sophia, here's what I would say. Because Sophia's like, I don't like approximating. I don't like looking at this thing and saying, if this is about 8,000, then this graph would go about 55, and that I mean, it actually doesn't look like it crosses exactly there. It looks like it crosses a little bit higher than that. Maybe it's something off. You know, we're approximating it. So I mean, it's not necessarily an easy thing to do from the graph. So what I'm suggesting, or what at least Sophia is suggesting, is that we actually solve for the exact answer. We solve for the thing, and we have the power to do so because we know the quadratic equation. So let me just plug this into the quadratic equation. To do that, before I do that, let me mess with this thing a little bit. I'm going to make this x squared minus 200x plus 8,000 is equal to 0. And the reason for that is because I want to put it in standard form, so I need to make it equal to 0. Apparently my a is equal to 1, b is negative 200, and c is 8,000. Oh, no, it's not negative x squared, because what I did was I took everything and I put it over to the left-hand side. The negative x squared over here became a positive x squared, whereas the 200x became a negative 200x, and then I still have the 8,000 left over. Oh, I see what you're saying. Sophia, what you're suggesting is we take everything, we take this equation over here and we move everything over to the right-hand side. So what you're suggesting is this. Negative x squared plus 200x minus 8,000 equals 0. Is that what you're saying to do? Okay. Well, let me tell you this, Sophia. If you apply the quadratic equation to this one or this one, you'll get the same exact answer. Because all you're doing by doing your suggestion is you're multiplying this by negative 1. Well, if I multiply this by negative 1, right, because that would make negative x squared plus 200x minus 8,000, it would multiply the 0 by negative 1, but that doesn't change anything. And yes, Sophia, the reason why I chose this one that I chose is because I like using less negatives. I don't like dealing with so many negatives. That's why. I mean, that's really it. All right. So let's see. 200 plus or minus the square root of 200 squared minus 4 times a times c, so that would be 4 times 1 times 8,000, all divided by 2. Help me out with the calculator. I'm not very good with this one. This is 40,000 minus 4 times 8. 32,000? Square root of that, let's see, 200 plus or minus, and I got this over 2. And then I'm going to do 200 plus or minus 8,000? Anyone know what the square root of 8,000 is? Someone tell me what the square root of 8,000 is. Or I'll just look it up on my own. Oh, 89.44. Okay. So what I'm looking at is 200 plus or minus 89.44 divided by 2. And what is 200 minus 89.44? Sorry. Let me just fix that a little bit. 89.44. What is 289.44 divided by 2? 110? Okay. 110.56. And then we'll also go with the minus version. Or, I'm sorry. I accidentally did. Oh, wait, you're saying 200 minus 89.44 is 110.56? Oh, yeah, okay. Divide that by 2. What is that? It's like 55.28. Is that what you got? All right, cool. Also, what is 289 divided by 2? Or 289.44 divided by 2? I should have a calculator on me, and a lot of times when I teach class, I have a calculator with me, but I kind of want to make sure that everyone's paying attention. All right, 144.72. Okay, good, awesome. 144.72. So this answer right here gives me two answers. One is with the minus version, and when you plug in a minus for this plus or minus, you end up getting 55.28. And when you plug in a positive for that plus or minus, you end up getting 144.72, which is a good thing, which is an extremely good thing, because we guessed that this thing was going to be about 55. Was it about 55? Yeah, we were pretty darn close. It was actually 55.28. So it wasn't exactly 55. It was about 55. And no, you can't actually click on this point on Desmos. It doesn't actually give, you can click on this point on Desmos and it will tell you the coordinates, but not this one right here. You also, this thing wasn't exactly 145, which is what we've thought it was going to be. This is actually 144.72. So here's what I'm saying is when they ask you to graph the thing and estimate it based off of your graph, okay, we can guess it. We can get a ballpark figure. When they ask you to calculate it, which I think is what the second part asks you, it says, using the graph, approximate the dimensions of that. What dimensions would yield 8,000 feet squared? Well, that's what we did. Then using the symbolic representation, check your answer to G. Was it close? And the answer is it was absolutely close. It was extremely close. Does that make sense? Yeah, when I say estimate, I guess you can estimate it based on the graph, and I would probably draw the graph on Desmos because Desmos does the much better job than my hand, and a much better job than your hand after looking at some of your submissions. No offense. It's just a graphing calculator will graph much better than a human hand. So here's my question for you: Is guessing based off of a graph even worth it? Because we guessed based off a graph, we got close, but we didn't get the exact answer. Is having these graphing skills even worth it then? Yeah, and I would say kind of it's pretty close, and I would say actually it's extremely worth it, because at least if I go through this massive calculation and I get one of my numbers to not be 55, but let's say it was 73 or something like that. Instead of 55, I got 73. Then I would say, maybe I accidentally dropped a negative somewhere. Or maybe I accidentally screwed this calculation up, because it sure doesn't look like 73. You know what I mean? So I would say the graph is extremely useful. All right. Moving on. We got more stuff to cover, more stuff to do. Yeah. What I would do is if my graph doesn't look anywhere near my calculation, then I know one of two things is wrong. Or, actually, at least one of two things is wrong. Either I screwed up the graph, either I screwed up the calculation, or I screwed up both. All right. It looks hard and I hate cylinders. So, all right, fine, let's do this one. This one's actually not so bad. Suppose that we have a cylinder below under the faucet and it fills it up with water. The height of the cylinder is 10 inches, but the radius is unknown. So we know that the height is 10 inches. The radius, we'll just leave it as r because we don't know it. The water enters the cylinder at a rate of 2 inches cubed per second. All right. So the rate, or let's say, yeah, I want to use rate as in, maybe I'll go with speed. So the S is equal to 2 inches cubed per second. So, and I chose S because I didn't want to choose R for rate because I have R for radius, and I also didn't want to choose V for velocity because I have V for volume. So I chose S for speed. The speed at which the water goes in is 2 inches cubed per second. All right. If the cylinder fills up at 20 seconds, what is the radius? Okay, all right, let's try this one. I know that the volume of the entire thing is actually 2 pi, or I'm sorry, not 2 pi r. It's pi r squared times h. What is pi r squared? I'm just curious to know if you know that. It's the area of a circle. Okay. So pi r squared, that's where that area comes in. And then when I multiply by h, what I'm doing is I'm stacking h amount of these circles on top of each other to figure out exactly how much the volume is, because I got the area of the circle and I multiply that by h and I get the volume. So this is actually v as a function of r. Keep in mind that that's not v times r. This is v as a function of r is equal to pi r squared times h. Got it? So they told me that it takes 20 seconds to fill up this whole cylinder, and the speed at which this thing was moving at is 2 inches cubed per second. So what's the volume? What's the volume of water that went into this thing? If it's filling up at 2 inches cubed per second and I went for 20 seconds, then apparently it's 40 cubic inches. Yeah, duh. Okay, all right, fine. Oh, it wants to find the radius. So it told me the volume that this cylinder is at, and I want to figure out the radius. So I'll just plug in 40 here equals pi times r squared times h, which was 10. And I want to figure out what r is. Okay. 4 equals pi r squared. R squared equals 4 divided by pi. R is equal to the square root of 4 divided by pi. Someone tell me, what is the square root of 4 divided by pi? I'd imagine it's something close to 1. I bet you it's like 1.2. I'm just guessing at this point. 1.14, that's my guess. Yeah, no, I want you guys to actually calculate it out. The reason why I'm guessing 1.4 is because I'm thinking, 4 divided by pi, that's a number close to 1, but it's a little bit bigger than 1 because 4 is a little bit bigger than pi. And then you square root it. And so the square root of 1 is close to 1, so it's a little bit bigger. So is the answer 1.13? Because my guess was 1.14. Dang, I'm good. Yeah, buddy. I can't believe I got that close. I actually didn't look it up, beforehand. I didn't calculate it out. I just guessed it. Yeah, I'm a baller like that. I throw basketballs backwards and then shoot them. That's just what I do. All right. Anyway, Yeah, no. I mean, I took you through my guessing process. As I said, all right, 4 is a little bit bigger than pi, but it's kind of close, so it's about 1.5 maybe. And if you take the square root of something close to 1, you're going to get something close to 1 still. I'm guessing it's going to be a little bit bigger, so I just kind of guessed between 1.2 and 1.1. So I guessed 1.14. And that was actually just a random guess. But that was kind of my thought process through that. Anyway, how fast could it fill up a container if the radius was 2 inches? All right, so if we go back to our equation and we want to figure out that the volume is, what is the volume of a container of 2? So that would be pi times 2 squared times 10, which is pi times, what is that, like 40 pi? 40 times pi. All right. And that's the volume. So if the speed is equal to the volume divided by the time, then I want to figure out how long it will take. I'll just say that the time is equal to the volume divided by the speed. So I just take this number, 40 times pi, and divide it by 2, because the speed was 2. So that's what? 20 pi. Again, I'm going to guess. I would say like 63. What is 20 times pi? No, it's got to be like 65 or something like that. I don't know. What is 20 times pi? 60. Ooh, my first guess was right. 62.83. I guessed 63. All right. We're playing the guessing game here, and apparently Mr. Dalday is doing really well with this game. All right. How fast would the increase happen if the radius was 4 inches? Yeah, it's asking the same question. It's just asking the different radiuses. Oh, wait. How fast would the container fill up if we increase the radius to 4 inches? Okay, yeah. So you basically just do the same thing, but you plug in a 4 here. Or actually, I think it's just twice this number, right? Now, if the radius was 2 inches and the height is 10 inches, we wish to fill up the container in 10 seconds. How fast must the rate be? I feel like we're repeating ourselves here. All right. I'm not going to do that one. These questions are pretty straightforward. I don't feel like it's asking anything super complicated. Do you guys agree? I think maybe the only complicated equation that they were talking about is the one you didn't really see is the speed at which it fills up things was 2 inches cubed per second. Now, I pulled this equation right out of the top of my head, v over t, but you can kind of get that equation by just looking at the units of this thing. Inches cubed is a volume. That's why I have a v. And seconds is a time. So I said, all right, fine, my speed is equal to volume divided by time. Be careful because we're using different types of equations. Usually they see this as velocity, and they see this as, I don't know, some slope, or I don't know what you would, no, m is slope. So, we're using different variables here. But, I mean, I kind of account for using different variables when I say some stuff like this, which is why we have this weird notation. Because look, see, this is the volume as a function of r, because we're holding the h constant. The h was actually 10 in this problem. So your volume isn't going to change as h changes, because h doesn't change in this problem. The r does. Or at least the r's are unknown here. Does that make sense? I just don't want you guys to get confused with these variables. All right, let's see. Graph the volume of the cylinder with height equal to 10 inches as a function of r, where r is the unit of inches. Okay. This cylinder would graph something like, all right, it's it was pi times r squared times 10. That was our volume as a function of r. So if this is r and this is volume, then really what I'm looking at is 10 pi times r squared. So that would be like 31. Oh, wait. 31.4 r squared. Right? Because pi is 3.14 and multiply that by 10 is 31.4. So what kind of parabola am I looking at? Am I looking at a happy face parabola or a sad face parabola? Happy face parabola. Am I looking at a vertically stretched parabola or am I looking at a vertically compressed parabola? Vertically stretched. In fact, quite significantly vertically stretched. It would look something like this. Maybe something more like that. Well, that's ugly too. Yeah, that's the best I could do. You guys see what I mean? Yes, only one x-intercept and only one y-intercept. Oh, okay. Now let's continue on, because this looks pretty interesting. Suppose we build another container that has radius 2 inches, but yet has an undetermined height. If we want the container to fill up in 10 seconds, what must the height be? Okay. So in this case, we have the volume as a function of h is equal to pi times r squared h. But we know what r is. We're locking in that value, so it's pi times 2 squared, which is 4, h. So it's 4 pi h. That's the volume, at least. And if they want to fill up this volume in 10 seconds, then they say, all right, my speed of my water is equal to the volume divided by the time. And I know that the volume is equal to speed times time. So the volume that I'm looking for is equal to my speed, which is 2, and my time is 10 seconds. So I have 4 pi times h is equal to 2 times 10 seconds. Did I confuse anybody with that line that I just wrote? Please let me know. Are you sure? Let's see. How do I know that the speed hasn't changed? It doesn't tell me in the problem, and that is actually a good question. But I suppose that maybe it's a good question because it's a poorly written. This is a poorly written question. So it didn't tell me that my speed, although my faucet changed. So I'm going to assume that it didn't. How's that for an answer? And then, okay, fine. I'll tell you where I got all these pieces of the puzzle. This v came from the 4 pi h came from the calculation right above it. You actually see it, so I'm not going to explain it too much. The s came from the speed, which I'm assuming doesn't change, so that's 2 inches cubed per second. And the time, they told me in the problem that they want to fill this sucker up in 10 seconds. Right there. So that's where I got this part of the equation. Are we still good? All right, cool. I want to solve for h, so I just say h is equal to 20 divided by 4 pi. What is that? 5 over pi? Someone want to tell me what 5 divided by pi is? I'll tell you my guess. My guess is going to be about 1.73. $1.59. I'm getting worse at this game. 1.73 is not that far. Yeah, 1.59. Good. And they want us to round it off to 2 decimal places. We're done. Now assume that you wish your 10-inch container to be filled up in 5 minutes. The rate at which the water must enter the container must increase, and the radius increases in order to still fill up the container in the same amount of time. Wait, what? Hold on. They're doing something funky around here. Let me see. Now assume you wish to fill up a 10-inch high container, fill up in 5 minutes. The rate at which the water must increase, or a container must increase, and the radius must increase in order to still fill up the container in the same amount of time. Find the symbolic representation for R, the rate, as a function of radius in order to fill up in 5 minutes. Oh, okay. So I guess they didn't use an S, they use R. But when they're talking about capital R, they're using a rate. And when they're talking about little r, they're talking about a radius. So they're saying, all right, the volume is equal to your rate times your time. And they want to figure out what this R is, this capital R. So the rate is equal to the volume divided by the time. And we know what the volume is. The volume is pi times r squared times, they said that the height was 10 inches. So I'm just going to put 10 inches. Divided by my time, which actually I'm going to do 300 seconds. Where did I get the 300 from? Well, they told me 5 minutes, so I definitely don't want to put a 5 down there. I'm just going to do 5 times 60, which is 300. Yeah, 300. Because I want to measure this thing in seconds. So, look, this is my rate as a function of radius is equal to pi r squared times 10. Maybe I'll just do divided by 30. Because I took one of the zeros up here and I canceled out with one of the zeros down here. This is my rate as a function of radius, r and r. Now, I'll be honest with you, this whole problem I've been using S instead of capital R because I didn't want to go through this funky thing that they told me they want me to do, which is use capital R as the rate and the lowercase r as the radius. But apparently that's what they wanted me to do. You guys have just got to be good at doing those notations and whatnot. We cool with that? I'll be honest with you, I feel like the more interesting problem here is getting the cost of this. What is this? Almost like a swimming pool that you could build. Just multiply everything by a factor of 10 or larger. You know what I mean? It's like, how much would it cost to build something like this? That would be kind of fun to do. All right. I'm going to skip the rest of it because the rest of it is actually your homework. Somebody asked me, and we're going to go pretty soon. I'm going to be done. I've lectured on chapter 6. We're done with it. Yeah, the rest, this page and this page is your homework. This is what I gave you for homework. I'm so sorry, Bradley. I'll make sure to put up this stuff on the YouTube. I'll post it up by tomorrow morning. I'll be honest with you. The best way I did this was I actually made a spreadsheet, and I think somebody emailed me and asked me if I got all of my initial velocities wrong, or maybe the time. What was it that they asked me? The time or the velocities? Let me double check something. They asked me if I screwed up the last 10 problems. And I don't think I did. I actually think that I did it right the first time. But I'll tell you what I'll do is I'll double check it. Because I think that they got everything right except the last 10 questions. And what were the last 10 questions? Oh, the last 10 questions were the time. You know what? I made sure that my question 11 to 15 was correct. But what I didn't double check was if my questions 16 through 17 or 16 through 20 was correct. So I'll double check that and make sure I got it right. But when they asked me and they said they screwed up questions 11 to 15, I actually ended up getting it right in the first place when I originally did it. So, I'll check to see if I did 16 through 20 right or wrong. And I don't think I messed that up. Anyway, I got to go. We got to start up chemistry class. So I'll talk to you folks later. Okay, bye.